Hello, final topic on vectors, modeling with vectors. So make notes as per usual and we move on, have a quick look at an example. So example, girl walks 2 kilometers east from point O to a point A. So we can draw that. Two kilometers east, and then she walks 3 kilometers south from A to B. Find the distance traveled. Well, she's walked from O to B, so that's going to be 5 kilometers. So that's quite nice and easy. Then we need to find the position vector of B relative to O. Sorry. So we want to find the position vector of B from O. Now, if we look at OB, the vector is given by the travel down in the x direction, which is the I component, and then the travel in the y direction, which is negative j. So we can say the position vector, if we write the answer of B here, so B, we can say OB is given by 2i minus 3j. That's B done. Part C, they want us to find OB, the magnitude of OB. So nice and straightforward, especially after the previous exercise. So we want the magnitude of OB is given by the square root for the I component, which is 2 squared, plus the j component, which is minus 3 squared. So that's going to give us the square root of 4 plus 9, and that's the square root of 13. You can solve it or just leave it as the square root of 13. I'm happier with the square root of 13. And finally, the bearing of B from O. So the bearing of B from O. Now, if we have a north here, you know this is 90 degrees, then we need to find this angle here. And if we add 90 plus that angle, that'll give us our bearing. Because remember the three properties of bearing: 3 digits, starts from north and travels in a clockwise direction. So to find this angle here, this is a right angle triangle. We can use SOHCAHTOA. So let's do D here. In order to find the angle, we know relative to that, we know two sides. This is the opposite, this is the adjacent. So we're going to be using tan. Tan of theta is equal to opposite 3 divided by 2. So theta is equal to tan to the minus 1 of 3 over 2, which you're going to use your calculators to work out for me. And it is 56.3 degrees. So the bearing is equal to 90 plus the 56.3, which is equal to 146 degrees, 0.3. Good. Nice and straightforward. So if you can make some notes, hit pause when you're ready to look at the next example, hit play again. Okay, in this example we've got an orienteering exercise. The cadet leaves the starting point O, walks 15 kilometers, bearing of 120 degrees to reach A, first checkpoint, so 120 degrees. Then he walks 9 kilometers on a bearing of 240 degrees to point B. and from B he returns directly to O, so we've got to find position vector of A, the magnitude of OB, the bearing of B from O, and the position vector of B relative to O. That's quite a lot. So if we, first things first, we're going to sketch the points. It's impossible without a diagram. So we're starting at O, 15 kilometers on a bearing of 120 degrees, so that's more than 90. So I'll be going down there. So from O to A is 15 kilometers. And then at A, we put a north here, and the bearing is 240 degrees. And then it travels for 9 kilometers. There we go, that's our 240, and then we measure 9 to a point B. After that, he returns directly to O. So we've got to find the position vector of A relative to O. So we want to find the position vector of A. Now, the position vector is given by the I component, which goes across that way, and the J component. Now, if we split this diagram into, we just take the OA section, and we just draw that, we can work out, if we draw a straight line here, a horizontal line, then we're going to be left with 30 degrees here, 15 kilometers. Then we can work out the I component going across and the J component going down. So let's do a sketch. There we go. So that's just OA. It's nice and simple. We're not looking at the rest of the diagram, just this section. And we can form our little triangle there. So if that's 90 up to the horizontal, then we've got 30 degrees left over. So that's 30 degrees. So I want to find, let's call this X here. I want to find O to X. Relative to 30, this is opposite, this is adjacent, and this is my hypotenuse. So I want to find A. I'm going to use my, let's write SOHCAHTOA here. Adjacent, and I know my hypotenuse, so I'm going to use my cosine. Cos of 30 is equal to A over H, so A over 15. That means A is equal to 15 cos 30. Work that out on my calculator. That's going to give me 12.99. I can round that to 13. 12.99, so approximately 13. And I'm going to look at finding AX there, or the opposite side. Now I need to use my sine, opposite and hypotenuse. So I can say sine of 30 is equal to O over H, O over 15, and so O is equal to 15 sine 30. Work that out on my calculator. That's going to give me 7.5. So I can write my position vector OA in terms of I and J is equal to 13i, because it's come across from O to that point X there. It's gone down then to A, so it's going to be minus 7.5j. So we've got an answer for the first question. You want to hit pause, make some notes, and then we move on to finding the magnitude of OB. Okay, so for part B, the magnitude of OB, we've we're going to use what the diagram we had in the first bit. So we're going to draw that line across there. When we draw that line across to complete that diagram, if you recall, this angle here is 30 degrees. This is 90 degrees because it's a horizontal hitting a vertical. That means we're left with 60 degrees here. So if that's 60 and that's 240, we're going to be left with 60 plus 240 is 300. We're going to be left with 60 here to take it up to 360 degrees. So now I have one side, another side, and the angle in between them. So I can use that to find this length here, OB. Now I don't have, my triangle is not necessarily a right angle triangle, I don't know that. So I can't use any of the SOHCAHTOA or Pythagoras, which means I have to use sine or cosine rule. And it's two sides with the angle in between, so it's going to be cosine rule. So if we label this triangle to help us, call this side opposite A, small a, this side opposite angle B, small b, and then this side opposite the origin, and call it small o. That's going to be confusing. Let's call it C. We'll put a C here for the angle. That makes it much easier. Now I know you recall the cosine rule. A squared is equal to b squared plus c squared minus 2bc cos A. Now that falls quite nicely for us. B is 15 plus c is 9 plus 2 times 15 times 9 times cos of the angle in between, 60 degrees. That's not a plus, that's minus. And the easiest way, I think you can put all that in your calculator, do it as 1. So that means a squared is going to be equal to, when you work it out, you should get 171. A is the square root of that, which is going to be equal to 13.1 approximately, or say to 1 decimal place. So that's part B. Again, if you want to make notes, hit pause, make some notes, and then we'll move on to part C. Okay, to find the bearing of B from O, we now know all three sides. We know that angle there. To find the bearing, we need to find this and add it on to 120. So this angle here, theta, we need to find, add it on to 120. That gives us our bearing of B from O. So how can I find this angle theta? Again, I've got a triangle. It's not necessarily right angle, I don't know that. So I can't use SOHCAHTOA, so I'm going to use the sine rule in this case. So first I'm going to label my diagram, make it easier to work with. This is A, small a. This I'm going to call B, small b for that side. And this one I'm going to call C, makes it easier to work with. And this angle here I'm going to call big C. Right, so sine rule, A over sine A is equal to B over sine B is equal to C over sine C. So using that, I need to find theta. So I'm going to go theta, I'm going to go 9 over sine theta. So 9 over sine theta is equal to, and I know this 60 here, I know that's 13.1, so that's going to be 13.1 over sine 60. Now I've got to rearrange to get the sine theta on its own. So what I'm going to do is I'm going to bring it up to this side and then bring these two over the other side. So then it will be 9 times sine 60 that comes up there, and that goes down underneath to divide it, is equal to sine theta. Easiest way I would say would be to say that theta is equal to sine to the minus 1 of everything in the brackets, 9 sine 60 over 13.1. Put that in the calculator. That should give us, that gives us 36.5 degrees. And so the bearing is only 120 plus 36.5, which gives us 156.5. So as before, make some notes, and then when you're ready, move on to finding the position vector of B relative to O. And finally, part D, we want to find the position vector of B relative to O, which means we're going to come across to give us the I component, and then down to give us the J component. Now it's quite cluttered in there, so I'm going to draw OB separately. So if we give ourselves a little bit of room, we draw OB here. That's 13.1. Now it's going to travel (90 degrees). It's going to travel across and then down. So it's easier if we put the diagram like so. The bearing we just found out was 157 degrees. Is it easy enough? If we round it. So if that's 157, what's left here? So let's draw our line here, a north line. 156.5. So we're left with, take that away from 180. And that gives us 23.5 degrees. So that's 23.5 there. I can't fit it in there, so I'm going to write it here. 23.5 for that angle there. So I need to find this component here. This is opposite, and this is adjacent. So it travels across. Well, you could say you could put it across there and down there. It's the same thing. If I call this here, call it Y. So to find YB using SOHCAHTOA, I can use my right angle triangle trig. I've got opposite and hypotenuse, so sine is equal to O over 13.1. So O is going to be equal to 13.1 sine 23.5. I'll work it out on my calculator. That's going to give me 5.22 kilometers. That's 5.22 kilometers, and then I can work out the adjacent as well. This time I'm going to use cos 23.5 is equal to adjacent over hypotenuse. So A over 13.1, A is equal to 13.1 times cos 23.5, and that gives me 12.01 kilometers. So I've got my I component, and I've got my J component here. Just be careful with the J because it's going down. So I can say my position vector OB is given by 5.22i. So you can see it travels across there, 5.22, and then it goes down 12.01. So minus 12.01 J. And that's quite reasonable when I look at my diagram. So when I look at my diagram, it travels a shorter distance across and then a longer distance down, even though it's just a sketch. Okay, good. So that's our example. Time for you to do some questions. Hit pause, make some notes, and then I'm going to put some questions up for you. Some questions for you, exercise 11F on page 250 in your book. Up to question number 8. Good luck, off you go.